Can plug-in solar and residential solar work together? If you already have solar panels, a home battery, can you add one of these new plug-in solar and battery systems to your existing solution? This is a question I get asked a lot. People look at systems from companies like EcoFlow, Jackery, Anchor, and others and think, could I use one of these as a relatively cheap way of expanding my existing solar and battery system? Well, the answer is yes. Of course you can. But there are a few things you need to understand if you want the two systems to sort of play nicely together. And that's what we're going to look at in this video. Now, before we get into how we do it, let me say something important. If you already have a residential solar and battery system and you can economically expand that system, that is probably the best way to do it. Everything is integrated, the inverter knows what's happening with all of the solar panels, and it knows the state of charge of all of the batteries. And you can manage the whole thing as one system. But that's not always possible. Getting an installer back to expand an existing system can be expensive. Finding somebody willing to work on somebody else's installation can be nigh on impossible. And sometimes the equipment that you originally installed simply isn't available anymore. You may have an older inverter. The manufacturer may have changed the product range or the support level of that particular device. Or perhaps the battery you already have is no longer supported. So adding another battery to your existing system might turn into a surprisingly expensive exercise. And that's where these smaller plug-in solar and battery systems become really quite interesting. Because instead of modifying the existing installation, we simply add another completely independent solar and battery system alongside it. So let's start with, how does a normal solar and battery system work? And we'll start with the simplest possible solar installation. You've got some solar panels on a roof, on a patio, hanging on your fence, and they're connected to an inverter. The sun comes out, the panels start generating electricity, the inverter converts that into electricity that your house can actually use. And if your house needs that electricity when you generate it, you use it. And if you're generating more electricity than the house needs, the excess goes out to the grid. It's pretty simple. But now let's add a battery. The battery allows us to capture some of that excess solar rather than immediately exporting it. We can use that stored energy at any time we want. But that introduces another problem. How does the inverter know how much electricity the house actually needs at any given time? And that's where something called a CT clamp comes in. A CT, or current transformer, is normally fitted around one of the meter tails at the point where your electricity enters and leaves your home. Its job is essentially to tell the inverter whether electricity is flowing into or out of your house. So imagine it's evening, the solar panels aren't generating anything, and my house needs 500 watts. The CT allows the inverter to determine that we were importing around 500 watts from the grid. My battery inverter sees that and says, hang on, I've got energy stored in the battery. I'll supply that 500 watts instead. So it increases its output until ideally the CT sees approximately zero coming in from the grid. Now, somebody turns the kettle on. Suddenly the house needs another 3 kilowatts. The CT sees the additional import, the inverter responds, and the battery supplies more power. Turn the kettle off, and the process happens in reverse. And this is happening continuously throughout the day. The inverter is constantly adjusting its output upon what the CT clamp is telling it your house is using. And normally, that works brilliantly. until we introduce another independent battery system. Now let's imagine you've got two completely separate battery systems: a large residential battery system and a smaller plug-in solar battery system. They both have their own CT clamps monitoring the grid connection, and the house suddenly needs about 500 watts. Both systems see that import. So both systems potentially think, I can supply that. One of them will respond slightly faster than the other. Let's say your residential inverter gets there first. It supplies the 500 watts. The second system now looks at its CT and sees there's no longer 500 watts being imported. So it backs off. Then the load changes again, and both systems respond again. Depending on how these particular systems have been designed, their response times, and the way their control software works, you could potentially end up with two control systems continually reacting to each other. One increasing its output, the other backs off. The load changes, they adjust again. You may find that one system simply wins most of the time, and the other doesn't do very much. Or you can potentially have the systems hunting around as they both try to achieve the same objective. So I don't want my independent battery systems competing with each other. So instead, I do something really simple. I give them different jobs. Now, this is really key to how I run multiple battery systems in my house. I divide them into two different types. I have what I call my demand systems and my baseload systems. My large residential solar and battery installation is the demand system. Its job's pretty simple. Follow what the house needs. If the house suddenly needs another 2 kilowatts, supply 2 kilowatts. If that demand disappears, stop supplying it. It reacts dynamically to whatever is happening in the house. My smaller plug-in systems don't do that at all. I give them a completely different job. They supply the base load. So let me give you a real example. During the day, my EcoFlow system is generating power from its solar panels and using any excess to charge its batteries. But I don't need it constantly competing with my main residential battery to try and supply the house when it really doesn't need to. Instead, I give it a particular time period, and I say to it, between 10 o'clock in the morning and 4 o'clock in the afternoon, I want you to supply baseload. During that period, I tell the system supply 450 watts continuously. Not 427 watts because that's what the house happens to be using, not 1.8 kilowatts because somebody turned on the kettle, just 450 watts. That's its job. And that's what I call my baseload. So let's see what happens. If the house is consuming 450 watts, the EcoFlow supplies 450 watts, job done. If the house is only consuming 350 watts, then potentially 100 watts might escape out to the grid, and because I have an export agreement, I will get paid for that. And to be honest, that's not the end of the world, even if it's going out at a time where you might earn less than you would if you were controlling the export. But now let's imagine somebody walks into the kitchen and switches on the kettle. Now our kettle can draw 3 kilowatts. The EcoFlow doesn't suddenly try and supply the load for the kettle. It carries on doing exactly what it's been doing all along and supplying 450 watts. My residential system sees the additional demand and supplies the difference. So rather than having two battery systems racing to supply the same load, we have completely different jobs for each system. EcoFlow supplies the base load, and the residential system, my SolarEdge system, supplies the extra demand. And that's the basic principle behind how I make the two systems coexist. Now, what about solar panels? Well, the same principle applies to solar. My residential solar panels belong to my residential system. They charge my residential batteries. My plug-in solar panels belong to my plug-in system. They charge those batteries. I'm not trying to connect the batteries together, and I'm also not trying to connect the solar panels together. They are independent systems that happen to be supplying the same house. And that's an important distinction. Now, what if you want to add another system? And this is where it gets particularly interesting. What if you wanted to add another plug-in system? Perhaps you've already got an EcoFlow system and you want to add a Jackery system. Again, I could give it another job. Perhaps the EcoFlow supplies my daytime baseload, let's say from 10 a.m. until 4 p.m. Then perhaps another battery takes over for the evening, maybe 6 p.m. to 11 p.m. That battery could supply the evening baseload while the TV is on, the lights are on, and we're generally using electricity around the house. Meanwhile, my main residential battery remains the demand system, waiting for somebody to turn on the kettle, or if the heat pump suddenly kicks in and starts to generate hot water for the house. That main residential system responds. The oven comes on, it responds. So I could potentially have several independent systems around the house without having them all trying to do exactly the same thing. Now, does that mean I think everybody should go out and buy a plug-in battery instead of expanding their residential solar system? No. If you can economically expand your existing system, that's still the route I would look at first. It's integrated, it's simpler, and you have one system managing everything. But sometimes the economics simply don't make sense. Perhaps adding another residential battery costs several £1,000s. Perhaps your existing inverter can't support any more capacity. Perhaps the manufacturer doesn't make your battery option anymore. Or perhaps you simply can't find an installer interested in doing a relatively small upgrade. Suddenly, a small independent system starts to look quite attractive. You could add a couple of solar panels, a small battery, and that could cover part of your daytime baseload. And then you could potentially expand it again later. It's a much more modular approach. Now, I should point out this isn't the only way of running multiple battery systems. Far from it. You could use Home Assistant, you could potentially use APIs from the different manufacturers, you could build automations that allow different systems to communicate. And some combination of inverter and batteries may coexist perfectly happy without doing any of this. Now, there are lots of clever ways you can approach the problem, but this is how I do it. And I like it because it's simple. It's not trying to make several completely different manufacturer systems cooperate with each other. I simply give each inverter a job. My residential inverter is my demand inverter. My smaller plug-in solar is my baseload inverter. And because that they're doing different jobs, they can happily coexist in the same house. So let's go back to the question we started with. Can you add plug-in solar and batteries to a house that already has a residential solar and battery installation?
Yes, we can. Yes, we did.
And I actually think this could become one of the more interesting uses for these smaller systems. Not necessarily replacing residential solar, but expanding it. Particularly in homes where expanding the original installation is difficult, expensive, or perhaps no longer possible. But rather than thinking, I've got two batteries, think about it slightly differently. You've now got two energy systems. And the question you need to ask is, what job am I giving each of them? For me, the answer is simple. One follows demand, the other supplies baseload. And that's how I make residential solar and plug-in solar work together. Now, if you're doing something similar, I'd really be interested to know what combination you're using. What is it that you've got as your main residential system, and what are you using as a plug-in system, and do they work well together? And particularly, how are you stopping multiple battery systems from trying to do the same job? Let me know in the comments below. I hope you found this video useful. I know a lot of people are looking at expanding their home residential batteries to incorporate some level of plug-in solar. So maybe this has given you an idea of how you could make it work in your house. With that, I'm going to sign off. I hope you found this useful. If I'm lucky, I'll see you back here real soon for another video. Take care. Bye-bye.